Okay, now we're going to go over a topic known as look-back time. Look-back time. When we look into space, we are looking back in time. We really are. We're actually seeing the way things used to be. Imagine other scientists. Imagine if biologists could look back in time and see dinosaurs or something like that. Well, in astronomy, we can do that. We can't help it. So let me explain. So the speed of light travels at a fixed speed, right? It's about 300,000 kilometers per second through the vacuum of space. That's about 186,000 miles per second. So every second it travels 186,000 miles. But the thing is, so that seems incredibly fast. So on Earth, it's just instantaneous. Something happens, we're seeing it, right? Everything isn't a problem. But space is so big that when light is traveling in between the stars, right? When we see the stars in space, it took a long time for that light to get to us. So in space, say you have a bunch of stars where the light is traveling. It seems like the light is traveling slow because the distance between stars is so great. It could be, millions and millions of miles. Well, if it's traveling 186,000 miles per second, it takes a long time for that fresh light. It just come off the surface of a star. It takes a long time for that light to reach another star. In our case, to reach us on Earth, distant stars. It takes a long time. So if something happens on that star, some event, it could take thousands of years, by the time that light reaches us. So let's look at a PowerPoint chart. Let me set this up. We're doing this a little bit old school. That's okay. Bear with me. You'll be fine. Not a big deal. Not the greatest production quality, but we'll be good. Okay. So let's lower this and look at that. Voila. Okay, so there's my screen. And we're going to go ahead and do this. Okay, look back time. So light, right? We're talking about light. We all know what light is. We can see light, right? It's an electromagnetic wave that allows us to see objects. So light travels, right? It travels to us from these distant objects out in space, right? It takes time for it to reach us, right? So we see a star as it was when that light left it, right? When it left that star. Okay, so that means that it took a long time for that light to reach us. When that light finally reaches our eyeballs, we're seeing what happened in the past when that light left the surface, right? This is called look-back time. You need to get used to this concept. We introduced this first class because you need to get used to this in space. If space is huge, distances are great. We need to understand that, right? So for the moon, when the astronauts are on the moon, or there's robots, there's rovers on the moon right now, crawling around, right? It takes a while. It takes 1 second. When we look at the moon, we're seeing how the moon looked 1 second ago, right? So if a meteor hit the moon, it would take a second for us to see that. For the sun, the sunlight that you're seeing, it took 8 minutes for that sunlight to reach us, right? There's the sun. Okay, there's a solar flare, right? We wouldn't know that for 8 minutes. Nearby stars, it can take years. The closest stars to our sun, right? Our sun is a star, is the Alpha Centauri system. There's Alpha Centauri. There's another star called Proxima Centauri. Proxima, because there's two stars that are orbiting around each other. Proxima Centauri is the closest star to us. It takes 4.2 years for that light to reach us, right? Years. So here's some stars, right? The distance, when you look in the sky, the distances between the stars that you see are enormous. Enormous. Thousands and thousands of what we call a light year. The distance it takes light to travel for 1 year, right? And they're far from us. Stars are far away. Space is huge, right? Most stars can take centuries, right? Galaxies, right? Galaxies are worlds unto themselves. A galaxy, like we live in a galaxy, and then you have a lot of empty space. You would have another galaxy. The galaxies are all millions and millions of light years away. Just incredible distances. It takes. So we're seeing when we see those galaxies, we're seeing the way they looked millions of years ago. right? Okay, so let's say you had a friend, you know, let's say you had an alien friend, right? There's no evidence. There's no evidence that there's aliens, you know, that exist anywhere. There's no evidence that there's aliens that exist. But let's say, you know, Ancient Aliens is correct. It's not that show, right? So let's say that you have a friend. He lives on Proxima Centauri, right? That's the closest star to our sun, Proxima Centauri, right? It takes 4.2 years. So if you had your phone and you hooked it up to a NASA, you know, a NASA dish, and it was pointed at Alpha Centauri, and you sent your octopus alien buddy, Zork, right, that lived on Proxima Centauri, you'd be like, hey, Zork, what's up? And then it would take 4.2 years for that text to reach Zork, right? So Zork would be there, right? He's doing his octopus thing. Who knows what it is, right? He's like, yo, dude, what's up, right? Sends you the text back. It would take another 4.2 years for that text to reach you. That's 8.2 years, right? So then you'd be in your life, and like it would be 8.4 years since you sent that first text. You get this text from Zork. You're like, whoa, man. So you'd send him another text, right? And then you'd get a text back, and it'd be like, who is this? I lost my phone. You know, can you upload your new number, right? And you're like, oh my God. So that's like another 8 years, right? So you'd return the text again, and it'd be another 8.4 years, and it's like, oh man, I had kids, I got divorced, right? And your octopus buddy's like, man, I understand, right? So it's the distance, that's the closest star, 4.2 years. The other stars are way, way, way farther, right? So that is the concept of look-back time. You want to understand that. That PowerPoint I just showed, that's posted to the page. Take a look at it and understand look-back time. All right, that's all, folks.